Aromaticity of the benzene. The molecular formula we know that is C6H6. The 6 carbon atoms are sp2 hybridized. Why are they sp2 hybridized? Because 1, 2, 3. So this is C, 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 H, 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 H. So 1, this is sigma with the H, and here it is forming sigma. So 3 sigma bonds means it is sp2. When there are 4 sigma bonds, we say it is sp3. So sp3. And when there are 2 sigma bonds, we say it is sp hybridized. So for this carbon atom, there are 3 sigma bonds. There are 3 sigma bonds. So it is sp2 hybridized. Each sp2 hybridized carbon atom forms sigma bond with 2 carbon atoms. So it is forming 1 carbon atom over here. If we consider this carbon atom, it forms 1 sp2 with this, 1 sigma with this, and 1 with the hydrogen atom, The 6 remaining electrons are in unhybridized p orbital. Which are the 6 remaining? The ones which are forming a pi bond. So the pi bond is formed by 1, 2, 3, 4, 5, 6. So the remaining 6 electrons are unhybridized because pi bond does not participate in hybridization. Does not participate in case of hybridization. So the neighboring unhybridized p orbitals each contain 1 electron overlap above and below the ring. Since the p orbitals are out of the plane of the atoms, these orbitals can interact with each other freely and become delocalized. Thus, instead of being localized to 1 carbon atom, each electron is shared by 6 carbon atoms in the ring. Now, how do you explain this part? See, very simple. There are 6 electrons we know which are unhybridized. So I will write here that we know there are 6 electrons which are unhybridized. So they are saying that if I am taking it like this, if I am taking a structure like this, then its equivalent structure, because these electrons are unhybridized, its equivalent structure can also be like this. Correct? So what is it trying to say? That this carbon atom has this electron and this electron is with this carbon atom. But now this carbon atom will have this electron and this carbon atom will have this electron. So basically this electron which is present over here, so the position of the electron has changed. It has completed one ring. So this has shifted over here, this has shifted over here. So basically the electrons are going on shifting. Because the electrons, they are going on shifting, it is said that each electron will go with a particular carbon atom. So suppose this is electron number 1. This electron has now come over here. So now this has become electron number 1. So this electron number 1 will rotate throughout the cycle and it will be shared by each carbon atom. This electron number 1 will rotate and it will be shared by each carbon atom. Therefore, the equivalent structure which we always show for benzene is a circle. Why? Because we are trying to say that the electrons which are present, they will rotate about all the carbon atoms. So we always show benzene by a circle rather than by 3 lines. Thus, instead of being localized to only one electron, which is not possible because it is a resonance hybrid, so it will undergo resonance. It will not be localized to one electron. It will be shared among all the 6 electrons. Thus, what can we say? We can say that each carbon is joined to its neighbor by 1.5 bond. Why 1.5 bond is said? If this carbon atom is considered, so let us consider these 2 carbon atoms. Let us say that this, with respect to this star carbon atom, this is the neighbor, correct? So this star carbon atom has one full bond. This is the one full bond, and this is the half bond. Why is this considered as the half bond? Because this half bond is going to go to that carbon atom also in due course of time because of resonance. This will shift. This will shift over here. This will also shift over here. Then this will also shift over here. So, because this will go with this carbon atom also at some point of time, because it is delocalized electron, therefore we say that it is shared by one full bond and half a bond. Again, see, this is there and this is the there. So this is suppose now this is the neighbor. This is the neighbor. If this is the neighbor, again the same thing, one full bond and one half bond, because this electron which is present with this carbon atom, so with carbon atom of blue star, this electron is present with this blue star carbon atom, but this electron will also go with this because it is delocalized. Therefore we say that this bond will be shared by both of them, and this full bond is a localized bond. It is a sigma bond. So one is a full bond and one is a half bond. So half bond is formed by the pi electrons and full bond is formed by the sigma electrons. So sigma forms a full bond and pi forms a half bond. Okay, next. 6 delocalized pi orbitals are formed, of which 3 are bonding with lower energy level and 3 are anti-bonding with higher energy level. So why is it said that 6 delocalized are formed? Very important, very simple also. See, like this it goes. So this is 1, this is 2, this is 3, and then goes like this. This is 1, this is 2, and this is 3. So there are 3 over here and there are 3 over here. So how many positions can it be shifted? It can be shifted up to 6 positions. Because if you again see the structure, what you get? You get this will go over here, this will go over here, this will go over here. This goes over here, this goes over here, this goes over here. So again this one structure 1, this is structure 1, this is structure 2, this is structure 3. So structure 1 equal to structure 3. Therefore, the positions which the electron can shift inside are how many? There are 6 positions. So we say there are 6 delocalized pi orbitals. We say there are 6 delocalized pi orbitals because there are 6 positions wherein that electron can actually move inside. For this third figure, it is same as the first figure. But the first and the second are different because this has 3 positions of its own. This has 3 positions of its own. So total there are how many positions? There are 6 positions in all. So 6 delocalized pi orbitals are formed, of which 3 are bonding with lower energy and 3 are anti-bonding with higher energy. 6 electrons are present in bonding molecular orbital. So they are saying that 6 electrons are present in the bonding molecular orbital. So let's see the molecular orbital diagram. How to draw the molecular orbital diagram for benzene. So this axis is the energy axis. There are 3 this thing and there are 3 this thing. So this is what? This is the anti-bonding orbital, and this is the bonding pi orbital. All the 6 electrons are in the bonding pi orbital because we say that all the 6 are bonded to the carbon atoms. So we show the 6 electrons, 1, 2, 3, then we fill like this, 4, 5, 6. So there are 6 electrons in the bonding and there are 0 electrons in the anti-bonding molecular orbital. Okay, so this is very important diagram, important structure to know. The molecular orbital diagram of the benzene goes with bonding there are 6, anti-bonding there are 0. And we know that the bond angle for benzene is 120 degrees and the energy, resonance energy, that means for this process to take place, for delocalization to take place, its resonance energy which is required is 36 kilocal per molar. So if this much resonance energy is provided, benzene will change into its resonance hybrid. So again and again you will see a shift of the electrons. So first 3 positions will be different, the next 3 positions will be different, and then again it will come back to its original this thing. Then again it will go to a second structure. So first it will go to the first structure, then second structure, then again second, then again first. Like this it will go on rotating because there are only 6 possible positions for the benzene.